Okay, so let's go to one more problem here. I'm going to try to actually do three of them. So we'll do this second one. How long will it take a shell fired from a cliff at an initial velocity of 800 meters per second at an angle 30 degrees below the horizontal to reach the ground 150 meters below? So let's see, how are we gonna focus on something like that? I'm gonna make a drawing, of course. Drawings are always important in these physics problems. And so I'm gonna start with a cliff. Get good at drawing cliffs right away. It's some sort of shell, so we're assuming that they've got some sort of howitzer or something like that. And it's got a barrel sitting here. I don't know, this is not a great howitzer, but we'll assume that there's some sort of cannon there. We could put a fuse, and there's this cannonball sitting right here. And they've decided to shoot it at an angle 30 degrees below the horizontal. So this is my horizontal. So this ball, or cannonball, is going in this direction, and then I suppose it's doing some sort of little thing where it's coming down like this a little bit. But this initial velocity, or initial angle, is 30 degrees. Okay. And then it's moving at 800 meters per second. And what else do we have? The ground is 150 meters below. So there's tons of information here. This should be hopefully a fairly simple problem to do. And so let's see what we have here. Let's see, how long will it take? So how long tells me right away that I want, t is what I want. And then I have an initial velocity of 800 meters per second and an angle of 30 degrees below. But so I have a u, but I have to kind of figure out the u, because what I want is the vertical u. I want to know what's the velocity going straight down. And since I have 30 degrees going in this direction, I'm just going to put a little line right here saying this is what I want. And so if I have the hypotenuse, which is what that is, but what I want is the opposite, I'm going to take the sine of 30 degrees and set that equal to 800 meters per second under my opposite, or my u in the y direction. Okay, and so the sine of 30 is 0.5, so this would be 400 meters per second. Okay, so this is one thing to think about with projectile motion. Anytime you're looking for the vertical velocity going up and down, it's going to be the sine of theta. If you're looking for horizontal velocity, it's going to be the cosine of theta. So my u in this case is going to be 400 meters per second. Okay, what else do I have here? I have s, right, 150 meters, and I always have acceleration because of gravity. We always know that's going to be 900 or 9.8 meters per second squared, and I should make that a negative because I'm coming down here like this. Okay, and so what I'm missing is, again, I'm missing final velocity. So since I'm missing final velocity, this is exactly the same equation as last time. Phew, that makes it simpler, right? So I'm just using s is equal to ut plus 1/2 at squared, which is a pretty straightforward equation. So let's write that in here. S is equal to ut plus 1/2 acceleration times squared. And then all I have to do is punch in numbers and I can solve the problem. So start with s. I have negative 150 meters. I have an initial 400 meters per second. And then we're multiplying that by time. And then I'm adding 1/2 times negative 9.8. So I should say, really, I'm just subtracting 9.8. How about that? That makes it a little easier. 9.8 meters per second squared. And then we're multiplying that by t squared. Okay, so let's clean that up just a little bit. How about we do negative 150? I'm going to get rid of those units because it's cluttering things up a little bit. And then I'm going to write 400t plus 1/2 9.8 is 4, or minus 4.9, and that is t squared. Okay, now we got a problem, right? I've got 150, but I have time twice. So this is looking a little bit like I need to use a quadratic formula, right? I've got t squared, I've got t, and then 150. And so what I'm actually thinking I will do is I want to just move the variables here over to the left side. So let's do this as, set that equal to negative. We can do, put this over here. So we can do, oh, you know what? I made a mistake here. So this 400 should be a negative also, because look, I'm going downhill. So that's also, this is also a negative. So I got negatives all over the place. So anyway, when I rewrite this, I'm going to write this as 4.9 t squared, because I'm moving this over here. And then I'm going to move the 400 over there. So plus 400t, move that over there also, minus 150 is equal to 0. So that's a pretty normal quadratic equation. I don't think I'm going to sit here and solve the quadratic equation, but just in case you do not understand how quadratic equation works, we take negative b is plus minus square root of b squared minus 4 times ac divided by 2a. And then this would be our a, this would be our b, this would be our c. And then when you would punch those numbers in, we would get two possible answers. More than likely, what you'll get a positive and a negative. Since we want time, we can't have negative time. We want whatever the positive number is. So I'm just going to punch those into a handy dandy quadratic equation solver, and we get an answer of 0.37 seconds. Okay, so that's relatively simple. Now I'm going to say that I do not think it's very likely that you will have quadratic formula on either the IB exam or the AP exam. It just takes too much time, and I think that the testers would not put that on there, but be aware of that if we have to solve anything. Okay, I'm going to do one more problem, and then we'll be done here. So let's do this third one. Give me some kind of idea how to do projectile motion problems. And so let's try this problem here. I blanked out the name. I don't know for sure if this actually was an actual name, but so pitcher X, how about that? Pitcher X throws a baseball with a horizontal component of velocity 25 meters per second. It takes 3 seconds to come back to its original height. Compare its horizontal range, its initial vertical component of velocity, and its initial angle of projection. Whew, that's a tricky one. So first thing I'm going to do is I want to draw a picture. So I've got some baseball pitcher right here, and he's throwing a baseball, okay? And it's going to go a certain amount of time to its original height, and so I've got a nice little parabola there. And it comes back down to its original height. It takes 3 seconds, okay? 3 seconds. And then we know that its horizontal component in this direction is 25 meters per second. So that's cool. And then let's see, what else do we have? We want to calculate horizontal range. Now, horizontal range probably won't be part of the kinematics equation, but every time I see anything that's asking me for horizontal range, I'm thinking I have to use kinematics to solve for time, probably. In this case, I have time, so that's kind of useful. And then its initial velocity component, we need to find out its initial velocity vertically, and then the angle. So we have angle of theta. And then we also want to know what's the initial, the u, and that's our question mark there, right? Okay, so let's start going through here first of all. First of all, I can solve one of the problems right off the bat. They've given us the information, because remember, one of the things we can do is if I have ux, in other words, my velocity in the horizontal direction, and then I multiply it by total time, this times total time, time total, how's that? That is going to equal my horizontal range, okay? And so that's being asked, so let's solve that right away. 25 meters per second is going this way, times 3 seconds is equal to 75 meters, okay? So there's the answer to question 1. All right, next thing I need is, the angle is probably something I'm gonna have to wait till the end to figure out, because right away I'm thinking if I have this number and I was able to get this number, well then I can just use an inverse tangent to solve that, right? So, or I think it's tangent, because what I'm gonna have here is I have adjacent and I have opposite, and so that means that opposite over adjacent would be tangent. So that should be pretty simple to solve. So let's concentrate on taking what we have and solving for that. So right away, let's have this as our variable that we want. I want to have my initial y direction velocity, and then that's our question mark, okay? And so one thing we know right away is that I have acceleration, which is negative 9.8 meters per second squared. Okay, that's good. I have, since I'm going to look at something that's going upwards like this, you know at some point it has to stop, so I'm going to have a final velocity of 0. That's always good. Anytime you have something that equals 0, it makes life a little easier. And then what else do I have? I have one more piece of information, and that is actually the time. So it's taken 3 seconds to go from the top to the bottom, since we have no air resistance issues or anything like that. If it takes 3 seconds to go up and down, that means it has to take 1.5 seconds to go up. So I have time equal to 1.5 seconds. And then what am I missing? I'm missing distance, okay? So go to my equation here. The only one that's missing distance is this very top one. V is equal to U plus AT. So let's try that one. V is equal to U plus AT. We are trying to find U, so let's isolate that. How about if I take U, or I take V rather, plus, or no, net minus, how's that? Minus acceleration times time. Gives me the number that I want, is equal to U. Okay, that makes sense. V minus A times T. Okay, so this is negative, so that's easy enough. And then the negative of 9.8, the negative of negative 9.8 times, so we'll just say that's positive there, times my acceleration, which is 1.5, or my time rather, is equal to 14.7 meters per second. Okay, that was easy. All right, so that gives me a U of 14.7, and then we should write that down, 14.7, because that's one of the things you're asking. And then finally, I need to know the angle, and so since I have opposite and I have adjacent, I can use the TOA part of SOHCAHTOA. So then the inverse tangent, which means I'm going to take 14.7 divided by, 25, right? This divided by that. I don't have that in my head, so let's try this. 14.7 divided by 25, and then inverse tangent gives me about 30.5 degrees. So my angle is 30.5 degrees, okay? All right, it's a pretty complicated problem. There's a lot of steps to it, but as long as we just started out slowly, we did drawings, and then we just took it step by step, you should be able to get through these projectile motion problems.